In today's lesson, we are going to graph sine and cosine functions. We're going to start with the basic form, kind of the parent function of sine and cosine, and then look at all the transformations that we can do. Today's lesson, we're going to kind of look at each transformation separately, and then the next video is when we're putting it all together, and it can get pretty complicated. But today we're going to try to keep it easy. So starting with the sine function, this is y equals sine of x. So you just think about an xy table, and then think about the unit circle. Sine of 0 on the unit circle is 0. So sine goes to the origin 0, 0. Let's look at these x values. We have pi over 2. Sine of pi over 2 is 1. I'm just going to go, we'll just label this up 4 is 1, down 4 is -1, just so we get a good graph. Okay, sine of pi is back at 0. Sine of 3 pi over 2 is -1. 2 pi is back at 0. Now, this pattern repeats infinitely in both directions, so I'm going to bring it this way as well. And what I like to do is I just like to highlight what is called one period of the function. So it goes infinitely left and infinitely right, but this sine function starts in the middle, goes up, down, up, and stops at the middle. So now let's compare that to the cosine function. Y equals cosine of x. If you think about making an xy table using the unit circle, cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1, 0, 1. So we have this. And again, if we reflect it over, it's going infinitely oscillating up and down in both directions, left and right. And then again, highlighting that one period from 1 to 2 pi. So you can really see what the cosine function is doing is it's starting up, it goes down, back up. And now we're going to start looking at transforming these functions. And first, we're just going to start with amplitude. And then we can do all these things here to change the function. But amplitude is just when we have a number in front. So in this scenario, we're going to do the sine function. There is no shift left, right, up, down. We're not changing the period. We're just changing the amplitude, which is how high the sine wave goes. So if you remember, sine starts at 0, 0. And instead of going up to 1, it's going up 3. Back to 0, down 3, back to 0. And keeps going infinitely in both directions. And once again, boxing in one period of the function, and then here you can clearly see the amplitude. Okay, now we're going to transform the cosine function by changing the period. And then changing the period comes from changing the b value here. So I'm just multiplying a number to x inside the function. And to figure out what the period is, you do 2 pi, so that's the regular period, and you're dividing by the absolute value of the b value. So in this case, 2 pi divided by our b value is 2, it equals pi. That means that sine, we're on cosine, sorry, cosine starts up, it goes down, it comes back up. And usually it does this from 0 to 2 pi, but now we have to do that same full rotation from 0 to pi. So to find the intervals, in this case it's pretty easy. If you take your period and divide it by 4, it helps you figure out what your intervals should be. So in this case, pi over 4. So there's no shift, so at cosine we're still starting at 1. But now instead of going here, we're going here. And then at pi over 2, we'll get to -1, back to 0, and back up. So here you can see that that is the like 1 rotation of cosine, but it's from 0 to pi. And then this would continue over and over again. So all we've done is changed essentially the width of our box, our period change. So it's doing all of it in a shorter time. Okay, so now we're looking at a phase shift, which is also a horizontal shift of a function. We're going to do sine again. And that involves both b and c. For today, we're just going to be changing the c. When you start changing the period and the phase shift, it gets complicated, which we will do in our next video. So here's an example. Notice how I'm going to change the amplitude and have a phase shift. So the phase shift is, you could think of it as the opposite of c divided by the absolute value of b. In this case, our b value is just 1. And then if you think of this as a negative pi over 2, and then this negative double negative would be just a positive pi over 2. Or if you just think about how we have translated all other parent functions, when we have a minus, that always means we move right. So just picture, so the sine wave is still, the period is still going to be 0 to 2 pi. We didn't change that. So this is 0 to 2 pi, but now we've just shifted these points right, pi over 2. So instead of starting at the origin, we're starting at pi over 2. And then over pi is when it goes up. Oh, the amplitude is 5. We're going all the way up here, back down to negative, and here. So here is, 1 rotation of the sine curve. And then it keeps going on. But if we highlight that period, the length of the period is still 2 pi. That's the length of our box, but it has just been shifted to the right, pi over 2. Okay, and our last example is a vertical shift, and that is when we change d. Add or subtract something at the end of the function will shift it up or down. So what's helpful is to just think we're shifting the midline. If you think about the x-axis as the middle, we're shifting that middle line. So in this example, I've got amplitude 2. This is shifting the midline to this line right here. So I'm going to go down to -3, and here's my dotted line. That is now the middle. Okay, cosine, if you think cosine, it starts up, it goes down, it goes back up. And that's at 0, and that's at 2 pi. So we have not done a horizontal shift. We're not changing the period. So our graph is still going to look like this from 0 to 2 pi. It's shifted down. So if you think of kind of right here, this is not a point, so don't plot that point, but this is like our starting area. We need to go, let's see, the amplitude is up 2. So I'm going to go up 2. And at pi over 2 is when you hit the midline. And then at pi, we got to go down to 3 pi over 2, we hit the midline, and 2 pi back up. So as you can see, it looks like cosine is just shifted down, and you can continue it. So there is your video on just kind of the basics of graphing and transforming sine and cosine functions. Good luck with your lesson.